In this video I'll go over solution for 1504 count submatrices with all ones. Given mn binary matrix match, return the number of submatrices that have all ones. Okay, so an example here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how do we do this? Well, we can just I tried a lot of things. I tried to do it seems that only one way works. What did I try? I tried to count the number of vertical ones. So 1, here's a 2, and so on. But essentially always you can also count the square ones. That was from previous day, but you always get a problem if you have more. An example, 3 times 2, that's complicated. It's easy to calculate 3 times 1 and this, but yeah, other ones are pretty hard to come up with in m times n time. But let's do what works. So one of matrix call is one of matrix 0. I'll even need a helper. I have count is 0. So essentially what works is this: 4 row in range row, or column in range columns. So if matrix but mat if mat of row column is equal 1 and column is greater than 0, then mat of rc is equal mat of rc minus 1 plus 1. So essentially we're just stacking. This will be 1, 0, 1, 1, 2, 0, 1, 2, 0. And here is the trick. So we have to take so what we currently have, and now for I in range R minus 1, or we can even do R minus 1. But since if it's 0, maybe this also works. Or let's not do it. So current is equal min of mat IC and current. So essentially what we do, so we have 1, 1, 1, 2, 1, 2. So what do? We go row up by 1 and see what was maximum there. So here it was 2, and we check 1 above and we add minimum of those 2. So if this was 3 and this one was 2, that would mean we have 3 here and 2 here. We would add 2 because what we can build is this one and this one. So here we would add 1 because we can build this one, and we will already add 2 for this one and this one, the one that is over there. So kind of tricky, but yeah. So this, if current is equal 0, so we cannot stack. So we already done these. Now we are trying to do these, but we do it the maximum we can. So if we had 2 This one is already settled here, so if we have here 2, then we take this one and this one. When you think about it, it makes kind of sense. Break count plus equal current, and that's, I guess, it. And you see it works. What's the time and space complexity? Well, in my term it would be RC or MN, and here it will be R times C worst case, because we go each row, each column, and then we go back. So once more, why does it work? Let's see this example. So first we count 1, we count 1, that's 2, we count 1, that's 3, we count 1, that's we count 2, that's 5, because we count this one and this one. I apologize also for the noise. Then here we also have 6, we have 8. But now, that's for that part, but when we are already here, we check one line above, it's not 0, it's 1, we add this one. Here we check again above, it's 1, we add this one, it's again 1, we add this one. Here we have nothing to add, here we have this one. So essentially, and we add this one also because it's 2, 2, so yeah, kind of tricky, but if you know the idea, then not really. But I guess you just have to train, practice, and these type of things, I guess, will stick. Do I understand? I mean, I understand. So, an example, wherever we are, let's maybe once more go here. So we have 1 here. We have 1 here. Okay, that's 1. We then come here. That's also 1. That's 2. We come here. That's 3. But since we can go up, we check what is the minimum of these 2. It's 1. We add this one. That's 4. Then we come here. We add 2, that's 6 for this one and this one. There is nothing up, so we cannot do anything. Here, nothing. Here we have 1, that's 7. We go up 1, that's 8. We go up 1, that's 9. Here we add 2, that's 11. And we go 1 up, and we add 2, because this is 2 and this is 2, that's 13. 4, so this and this, and yeah, we go 0, that's the end. Kind of makes sense, you just have to, I guess, practice, and that's it. Yeah, let's wrap it up here. If you have any questions, leave a comment. I appreciate you for following in this video, and see you in another one.